Okay, so our next topic here, I am throwing a lot of nomenclature at you guys, is we're going to learn how to name acids. We are not really going to talk about acids and what they do and how they function until spring semester, when we will have an entire unit on acids and bases. But we are going to be learning how to write our own chemical reactions next unit before we get done with the fall semester. And there will be a lot of acids in there. So we'll need to know how to name and write formulas for our acids. So I'm going to have us zip on in and learn what an acid is. So an acid, you guys, if I look, here's some examples. I see H leading off every single one of these things. So you know an acid when you see it, because you're going to see a big old fat red flag of H starting off your compound. So an acid is anything that starts with H and is bonded to a nonmetal, nonmetal, or polyatomic ion. Okay, so here I totally see hydrogen bonded to a fluorine nonmetal. Here I see hydrogen bonded to what is going on with that? That is a polyatomic ion phosphate. Here is hydrogen bonded to chlorine. Here is hydrogen bonded to sulfate. Here is hydrogen bonded to nitrate. Hydrogen bonded to the nonmetal iodine. Oh my gosh. So this is what I've got going on here. Now, one thing I want you guys to notice is hydrogen. We colored him blue because he is totally a nonmetal. But in acids, and in order to have an acid, technically every single one of these molecules in an acid are already dissolved in water. And what ends up happening, you guys, if this is a molecule of hydrogen and fluorine, they actually dissociate, which is so confusing. That goes against all you know about covalent bonds. You're like, I thought covalent, they did not dissociate. Ionic is the one that dissociate. But in acids, if it is hydrogen bonded to something else that is very electronegative, that actually will separate and those two things will dissociate. So what this means is hydrogen is actually acting like a cation, like a metal, because he is breaking apart and forming a charged ion. You're like, a charged ion? What do you mean? So you know why hydrogen here is in group 1 with the alkali metals? Because he's got 1 valence electrons. So if you wanted to, he could lose that valence electron and create a positive 1 charge. And that is what he does when he dissociates in water. That was a big tangent, but basically in an acid, hydrogen coming in hot first, he is acting like a nonmetal. So when I say an acid, it is hydrogen with a nonmetal or a polyatomic ion. And when I say polyatomic ion, I mean specifically the nonmetal negative acting polyatomic ions, okay? You're like, so this kind of looks like an ionic compound. Yeah, acids pretty much are ionic compounds. Since they have characteristic properties of that dissociation, they are ionic compounds, which is why when we get to the section down here at the bottom, when it says write in a formula, y'all, we're doing crisscross. So hopefully this isn't too much. We're doing crisscross here, but the beginning part, the naming, is a little bit hairy and a little bit squirrely. So let's talk about how we name acids. Well, naming an acid, luckily the first thing is always hydrogen, but where they can differ is what the second part of the compound that hydrogen is bonded to. And depending on that, we are going to have different naming rules. So my first option here is if I have, it got cut off, it says hydrogen, and if that hydrogen is bonded to a single element off of the periodic table, one of these guys, or a polyatomic ion without oxygen. You were like, well, who is a polyatomic ion that does not have oxygen? It ain't that many of them. Let's see. Everybody here got oxygen except for cyanide. Everybody here got oxygen. And ammonia does not apply to me because we are only considering my polyatomic ions that form anions, the blue ones. So basically cyanide. So if y'all want to write that, polyatomic ion without oxygen. Well, for us, it's only cyanide. There are other potential polyatomic ions that do not have oxygen. We are just not going to be using them for our course. Okay? So if I have a single element off the periodic table, I come in hot with hydro. And then whatever the root is of that single element, ic acid. So for an example, HCl, that's chlorine, single element off the periodic table. I would call him hydrochloric acid. So we've done some sneaky changes. Coming in with hydro, whatever that single element is, but we've changed the ending to ic, and then acid. Okay, so that's our first category, hydrosomething-ic acid. Our next two categories are dealing with my polyatomic ions. Now, besides cyanide and besides hydroxide, which hydrogen and OH will not bond together, HOH is 2 hydrogens and 1 oxygen, which is H2O. Anyways, everybody else in here besides my cyanide and hydroxide, which is not going to make an acid for me, all end in ate or ite, ate or ite, ate or ite, which is why my naming rules are only classified into whether you end in ate or you end in ite. Okay? If I have a polyatomic ion ending in ate, it does not start with hydro. You just name whatever the root of that polyatomic ion's name is, and you change the ending to ic, acid. So, for example, this is hydrogen bonded with phosphate. So phosphate, ate ending, phosphoric acid, right? My second category is the polyatomics ending in ite. We change the ending to us acid. So here is hydrogen bonded to sulfite. So sulfite will turn into sulfurous acid. And some of y'all are like, wait a minute, if it was sulfite, wouldn't you cut off the ite and it would be sulfus acid? Same thing with phosphate. If you cut off the ate, it would be phosphic acid. I know the naming is a little bit weird and crazy. I will not count off, especially when you are first starting, if you call it sulfus or if you call this phosphic acid. What I am seeing is the correct naming rules, and that is good enough for me. You will start to kind of get where the chopping off happens and how that name is actually represented when you turn it into an acid, and it will be fun. Trust me. Okay, so the most important thing here is I got to check every single one of these acids. How do I know whether she's giving me an ionic compound, a covalent compound, or an acid? Those are all different naming rules. I know it is an acid when I see hydrogen coming in hot. If hydrogen is the first element listed for me, you guys, he is totally going to dissociate and he will be acting like a cation. This is no different really than an ionic compound, honestly. So the second element will always be a nonmetal or a nonmetal-like polyatomic ion, okay? So now we just apply our naming rules. I put parentheses around polyatomics. Very important for you to see that it is one thing together that you need to name. Boom, 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 boom. Boom. Yes? Woo. All right. Here we go. Like we did when we did our mixed ionic and covalent nomenclature practice, I kind of like to, especially when I'm first starting, pick one of each one of these naming types and name them all together. Specifically, let's start with the hydrogen bonded to a single element. Okay? Those are the ones where I always come in with hydro something ic acid. So this is hydro. And it is fluorine, so fluor. Ic acid. Let's find another one. Chlorine. So hydrochloric acid. There we are. Hydro iodic acid. A little bit one that's kind of freaky and weird, right? So looking at all this, every single one of these, if it's a single element from the periodic table, is hydro something ic acid, hydro something ic acid, hydro something ic acid. But I also see a cyanide on here. So we would call that hydro cyanic acid. Cool. Okay. The rest of these are polyatomics. Oh, and I forgot to mention the way that I remember that ate goes to ic and ite goes to us. I think I ate something and it was icky. So we're going to write that maybe at the top. I ate something and it was icky. So that kind of grounds me. Ate goes to ic, which means ite goes to us. Okay, so here we go. Let's see. That is polyatomic ion. Who are you? That is phosphate. 8 is icky. So we do not start with hydro. If you've got lots of letters of the alphabet following your hydrogen, you better stop yourself and do not do a hydro at the beginning. So we are just going to go phosphoric acid. So phosphoric acid, because this was an 8, so we turn the ending to ic. Moving on down, that is also an 8. That is a sulfate. So we're going to call it not fic, but sulfuric acid. I know, like I said before, do not worry. I will be very understanding. I cannot talk and write at the same time. Sulfuric acid. I will be very understanding when we're getting started. Okay, you guys, I will not count off if you call it sulfic acid. I will be like, yep, they know what they're doing. Just do not call it hydrosulfic acid, because that would be a different naming rule. All right, next one. Ooh, that's an ite ending. This is nitrite. So if I ate something, it's icky. That means ite is us. No hydro. It would be nitrous acid. Okay. And this one is a true making sense of me taking off an ite and just plastering in an us. Okay, so sometimes there is some meaning behind it all. Okay, next guy. That, oh my gosh, who are you? Do not worry, it is an 8. It is an acetate, which means I ate something that was icky. So this is going to be acetic acid. Yes? Wonderful? Okay, I love this. I will let you guys chew through the rest of these over here. All of the ones over here are not going to be starting with hydro, because I got my polyatomics, and y'all, they all got oxygen in there. Just pay attention to the 8 in the ite ending. Ate something was icky. I ate something, or ite is us, right? Now, if we're doing the opposite, meaning I've given you a name and I'm writing a formula, guys, I told you what we are dealing with here is the hydrogen is acting like a metal. He is making a charged cation by dissociating in water when they are in acid. Okay? I'm crisscrossing. And the cool thing is hydrogen, group 1, he's always going to make a +1 charge, so he's never going to throw down anything of significance on the other anion, which is great. But depending on what the other anion is, I've got to be aware of, hey, that hydrogen may get a subscript, okay? And that's going to be important. Parentheses around your polyatomic ions when you're setting up this crisscross. We know that that is going to help me out a lot. Now, I need to very strongly look at the name to let me know who hydrogen is bonded to, but I will let you know if you see acid, that first letter in your formula better be H. Yes? The only thinking I have to do is like, well, who will be bonded to here? Okay? Remember, the things that start with hydro are my elements from the periodic table. Do we see any that start with hydro here? Yup. So hydrobromic acid is him bonded with bromine. If I bonded hydrogen +1 and bromine -1 charges, that crisscross result is going to be HBr. If you were like, I have no clue what she just did, let me show that crisscross over here out to the side. All I am doing, we said hydrogen is bonded to something else. That's what an acid is. He is bonded to bromine. Both of those have a +1 charge, or both of those have a 1 charge +1 and a -1. So I have a 1-to-1 ratio of each ion to each other. I also got hydrochloric acid. Starts with hydro, so he is with chlorine. Chlorine is a -1 charge. Hydrogen is a +1 charge, always, right? So it is a 1-to-1 ratio HCl. And then I got a iodic. So iodic, that is iodine. So I would be 1-to-1 ratio of HI. Sometimes I could do hydrosulfuric acid, and I kind of wish that was on here. Let's do that here at the bottom. Hydrosulfuric acid. So acid means hydrogen, so I'm going to have H plus crisscrossing with somebody else, right? Starts with hydro, so it's not a polyatomic ion, or at least a polyatomic ion with oxygen. It is sulfur. But in this one, sulfur has a -2 oxidation number, right? So that would actually be H2S. So that would be hydrosulfuric acid. Okay. All the other ones here on my list here do not start with hydro, so I know I'm dealing with a polyatomic ion. I am looking at that ending. If that ending is ick, that polyatomic ion's ending is 8. Okay, so ick means it came from 8. Ick means it came from 8. Ick means it came from 8. Us. On that next one came from an ite. Us came from an ite. Okay. Okay, so now I just have to crisscross. Remember, hydrogen, he's always got a -1 or +1 charge. I have to really pay attention to what the charge is on that polyatomic ion to see if hydrogen gets a subscript, if that charge on that polyatomic is anything greater than a -1. So nitric acid, that is totally nitrate. But he's got a -1 charge, so 1-to-1 ratio. So I have HNO3. You can put the parentheses around it if it makes you feel better. It is not required because I have one of them. Okay, chloric acid, that is chlorate, which is ClO3 -1. So ClO3. I got acetic acid, that's acetate, who has a -1 charge. So it is still a 1-to-1 ratio with the giant acetate polyatomic. So HC2H3O2. Sulfurous. That's sulfite. So sulfite is SO3 with a -2 charge. That means from that crisscross, which once again, hydrogen is always a +1, always. So it's not significant on giving any sort of extra ratio to that anion, that second guy. But this is going to let me know that I need 2 of those hydrogens for every one of my sulfite. So that's the formula for sulfurous acid because I have sulfite, right? And the last one I'm going to do over here is chlorous. Chlorous is chlorite. So chlorite is a lighter version than chlorate. So he's ClO2, but still with a -1 charge, which means it will be a 1-to-1 ratio, which will be HClO2. So the key thing here is hydrogen is always a +1, always in all of these crisscrosses, okay? So you have a few more polyatomic ion ones to chew through over here. Pay attention to the endings, because remember, if you ate something, it was icky, which means ite turns to us. So these are acids. Anything that comes in hot as with an hydrogen in the front, you know you're renaming with the acid rules, and it is acting like an ionic compound with the crisscross.